Okay, so um, we need to now look at how to first generate a prefix expression from an infix expression. The process is going to be very similar to what we did for postfix. So given an infix expression like this, apply the rule for operator precedence to decide how would you evaluate it as an infix expression. So it's the same expression we looked at earlier. So it will be A star B evaluated first, then C star D, then A star B plus C star D, the whole thing minus E. So in prefix, the rule is the operator comes first, followed by the left operand and the right operand. So A star B will be written as star AB. Then it is star AB for A star B. Then C star D will be written as star CD. So now we're going to have star AB plus star CD. So operator plus comes first, star AB, then star CD. So as we know by now, star AB is going to be A star B value, so it's one integer, and star CD is also going to be one integer. So then this minus E, so that's going to be like minus first, followed by this entire expression plus A star B star CD, and then the right operand is E. So you can remove the parenthesis finally and then say minus plus star AB star CDE. So that's the prefix expression for this infix expression. So when you just look at it, it may not make sense what it is really, but as if you use the rule that we saw for postfix, similarly we'll see the evaluation logic for evaluating a prefix expression. You will be able to evaluate the expression. Okay, so just remember the rule. So for prefix, the operator comes first, followed by left and the right operand. For postfix, the operator comes at the end, so left operand, right operand, and the operator. Alright, so now for the algorithm for evaluating the prefix expression is going to be very similar to that of the postfix. But there are two subtle differences. In the case of postfix, we scan the expression from left to right. So here we can either do this, we can scan the expression from right to left. So given this prefix expression, we can scan this from right to left. So that's one thing, that's one way we can do that. Or you can reverse this expression and scan it from left to right. So either way we are doing the same thing. So if you reverse this, if you scan from right to left, we will be looking at E first, followed by D, followed by C, and so on. If you reverse it and scan from left to right, we'll be still looking at E first, D, and C, and so on, because if you reverse it, it's going to become like what? E, after you reverse it, it's going to become E, D, C, star, B, A, star, plus, minus. Okay, so why I say the two different ways? Because if you scan it from right to left, we can kind of avoid using the reverse function, right? So if you have problem using the reverse function, you can simply scan this expression from right to left. But in that case, you have to know how to go to the end of the string and process it from right to left. So that's why I would really suggest using the reverse expression and then scan from left to right. Okay, so then it becomes like, how would you scan like a postfix expression from left to right? So once you reverse it, you can scan from left to right. So that's the first step. So you decide which way you want to go. So either way, you're going to do the same thing. Alright, so let us say we reverse the expression and process it from left to right. So this is what we have here: E, D, C star, B, A star, plus, minus. Okay, well, yeah, so or I read this expression right to left. Okay, so let us use this. Since I have it like that, let us use that. Let us read this expression from right to left. I have not reversed it, so I'm reading from right to left. Still, it's the same thing. Okay, so let us look at the details. If we see an operand, push it to the stack. So I see an operand E, right? So I push it to the stack. I see an operand again, which is a D. I push it to the stack. I see an operand again, which is a C. I push it to the stack. So now I see an operator. So when you see an operator, you have to pop the stack twice. And the first pop value becomes a left operand. Okay, so C star. Then you pop it again. The second pop value becomes a right operand. So that's going to be C star D is what you're going to evaluate. So after you evaluate C star D, you push the result back to the stack. So the first pop is the left operand, the second pop is the right operand, and then you do the C star D, and the result is now pushed back to the stack. So the stack looks like this: C star D at the top, which is the value 5, and then the value of E, which is 4. So now you're scanning from right to left. I have put it here. So now we are at B. So it's an operand, so you push it to the stack. So the stack will look like B at the top, and then we encounter an A, so we put A on the top of the stack. So after this, the stack will look like what I had earlier. So this is now the top of the this is now the contents of the stack. So the next symbol we encounter is an operator star. So we have to pop the stack twice. The first pop is A, that's going to become the left operand. The second pop is B, that's going to become the right operand. So you will be evaluating A star B and pushing back the result to the stack. So that's this. So this is now the contents of the stack. So the next symbol you encounter is a plus. Now the first pop becomes the left operand A star B plus C star D, and you push back the result to the stack. Then you encounter a minus, so pop the stack twice. The first pop becomes left operand, which is A star B plus C star D, and the second pop is the right operand, which is E. And you do the minus and push the result back to stack, so that's a 7 final result, and you have reached the kind of beginning of the expression in this case when you scan from right to left. So you can stop, and then whatever is in the stack is the final result of the expression. So it's the same expression that we evaluated both as postfix, prefix, and we get the same answer. You should get the same answer. So the rule is, again, to summarize, first generate the prefix expression of the given infix expression and either scan it from right to left and apply the same rule. If you encounter an operand, push it to the stack. If you encounter an operator, pop the stack twice. The difference between post and prefix is when you pop, in the case of prefix, the first operand becomes the first pop becomes the left operand, and the second pop becomes the right operand, and you push the result back of that operator evaluation back to the stack. And so this you can either evaluate it from right to left or reverse the prefix expression and evaluate from left to right. Okay. So let us look at the code for this. So given input a stack, initialize a stack, it's empty currently, input the expression for string, and this is why I showed you the reverse code before. You can reverse the expression using this logic. So the expression is a string dot begin comma expression dot end, so it will reverse the entire string, and that will be the updated value of this expression string, and then you can generate the character array for that expression. And this code, so I highlighted this code to show the difference between the postfix code and prefix code. So this code is going to be almost the same as the postfix code, except this point where you have the difference, and the rest of the code is going to be the same except one more point where the labeling, the first pop should be labeled as left operand, the second pop should be labeled as the right operand, and the rest is everything going to be the same. Okay. Any question on evaluating this prefix expression? Okay, so one thing you have to handle in your code for evaluating the prefix expression is this. So if your operands are single digit numbers like this, there shouldn't be any problem in reading it from right to left or left to right after the reverse. But let us say your expression is something like this: minus, plus, star, and then 1 2, and then 2 1, and then a star, and then let us say just 3, but this is say 5 4 6, some large number, and then 4 5, something like this. If this is your expression, how would you evaluate it? If you see here, if you either read from left to right or reverse it and read from read from right to left, or reverse it and read from left to right, either way, when you read from right to left, you will be reading it as the first token 453, right? That's going to be the value, but how would you know what is the rightmost index from which you have to read? So you have to develop the logic for that. So that's why I reverse the string, so that we can start from index 0 and read that string. So if you reverse the string, it's going to become 3 5 4 7 6 4 5 3, and then the star 1 2 2 1 star plus minus. So if you reverse it, this is what it's going to become. So we need to know or understand, we need to understand that what we have now is 3 5 4. So if you use this logic, this code I have here, and extract the token, what will be extracting is 3 5 4, not 4 5 3. So you have to handle this problem, and the solution is simple. When you extract a token here, right, add another reverse statement and like this, and say here reverse token dot begin and token dot end. So that will take care of reversing whatever we extract as token. So right now we extract 3 5 4, but it should be 4 5 3. So when you call the reverse function on the token, that will reverse that token to 4 5 3. Similarly, you call reverse on this token, it will reverse it to 5 4 6 7. If you call reverse on 3, it's still 3. So this logic is general enough to handle operands having just one digit or more than one digit. Okay. If you reverse, you're not going to reverse a star. Even if you reverse it, it's going to be okay. So you can reverse this here if you want to inside this if block, if it's an operator, You can reverse it only if it's an operand, or you can reverse it outside also, because if you reverse an operator, it's still going to be an operator, the same operator. So it's up to you. But if it's an operand, you have to make sure you reverse it. Okay, reverse the token. So if you reverse this token, it's going to be 2 1. If you reverse this, it's going to be 1 2, and then plus star if you reverse, it's going to be still the same operator. So that's why I suggested reversing the entire expression, scanning from left to right, and then reverse the individual tokens to get back the same integer if it has multiple digits. If you scan from right to left, the main problem is locating the end of the string and then processing that string from right to left. So that's why it's better to reverse it and just say we start from index 0, the first token, because the tokenizer is going to read from left to right. So that's why the logic of doing this way, reversing the entire string first and process it from left to right, and then as you encounter each token, reverse those tokens. Okay. So I'm not going to post this code in the zip file. This is actually part of a project assignment I may give as an assignment. So I'll give you the code for postfix and ask you to write the code for prefix. And I've actually shown you the code and it's recording in the video too. So it's going to be an easy assignment. You have to just do these changes to that code and evaluate the prefix expression. Okay. So that's going to be an easy assignment. Any question? Right, so with that we finished the stack module. So next time we look at the queue module. So stack is going to be last in first out.